In this problem, we're given information about the weights of randomly selected U.S. Army male personnel from 1988 and then from 2012. And in Part A, we start with using a .01 significance level to test the claim that the mean weight of the 1988 population is less than the mean weight of the 2012 population. So I'm going to say that group 1 is 1988 and group 2 is 2012. So our null hypothesis is that the mean for group 1 is equal to the mean for group 2. And the alternative hypothesis, which was the claim, is that the mean weight for 1988 is less than the mean weight for 2012. So my claim is the alternative, and we're ready to go ahead and do the test. Now, because this is about two means, and they are from independent samples, they told us here, independent random samples. So we're going to do a two-sample t-test. We're always going to do a t-test. We're never going to do a z-test. So that's for any of my students. If you're in another class or another school and watching this, that may not be the case. But in our particular textbook, we only do a two-sample t-test, and the population standard deviations, we are not assuming that those are equal. So we're going to say no when it asks us about should the values be pooled. So I'm going to do my two-sample t-test, which is number 4 on the list. And I start with my input, and that's going to be the data. They supplied us with a big list of data. And you can put that into your calculator, or you can use StatCrunch for this, so either way. And if I'm using the calculator, then I'm doing my list 1 is going to be L1, and the frequency for that is going to be 1. And list 2 is going to be L2, and my frequency is 1. And let's see, my alternative hypothesis is that mu1 is less than mu2. So we're going to select that. And then it asks me, is my data pooled? We're going to say no. And then you can calculate or draw. So if you were using StatCrunch, in order to do that, let's see, you're going to select, at the top, you're going to go to Stats, and then you're going to select T-Stats, because we're doing a t-test. And we're going to choose 2 samples. And then we're going to choose with data, because we have data. If we had the statistics, if they told us the sample mean and sample standard deviation for each group, then I would choose with summary. And my values, I select my column. So I'm going to use, let's see, I'm going to use 1988 for sample 1 and 2012 for sample 2 because that's how we set that up originally. The data is given in the reverse order, so just be careful about that. We do not want to pool variances. And so if I do my hypothesis test, I can choose that. And my null hypothesis is that mu1 minus mu2 is equal to 0. So let me put this in. So choose my columns, and then for hypothesis test, I'm going to put equals 0 for mu1 minus mu2 and less than 0 for mu1 minus mu2. You can think of this as just subtracting the mu2 from both sides in my alternative hypothesis, and we get mu1 minus mu2 is less than 0. It's equivalent to what we had there. All right, so I'm going to do my hypothesis test, and see what's my critical value or my significance value is 0.01. And there's a lot of other options, and I'm just going to go ahead and compute. And so I get my test statistic. Oh, there we go. Is negative 1.01. That's your t-stat. And then the p-value is 0.1615, and that rounds to 0.162. All right, so since the alternative was, the alternative hypothesis was the claim, I want to use the word support when I'm writing my conclusion. So we want to, let's see, our test statistic is negative 1.01. So I can use that and compare that to our critical values. And our critical t is negative 2.53. So that would tell me to fail to reject the null hypothesis. Or I can use the p-value, and that's larger than alpha. So again, I would fail to reject the null hypothesis. So I know A and B are wrong, and now I want to say there is not sufficient evidence to support the claim because we didn't reject the null hypothesis. So that means that we don't have enough evidence to support the alternative. So now I want to construct my confidence interval for this. So what I'm going to have to do is I'm going to have to figure out what my confidence level should be. So I'm going to erase what I have on the screen here to make some space. Okay, so we know that the area in the left-hand tail is 0.01 because that was our significance level. So that's our critical area. And I'm going to shade that in. We have 0.01 here. But when we're working with confidence intervals, we have to have a range of values centered in the middle of our distribution. So that means that because this was a one-tail test, and we had 0.01 area filled into the one tail, then in two tails, we would just double that and have 0.02. So I'm going to mark off my right-hand tail here. and that's going to be another 0.01. So total of 0.02, which means that my confidence level, what's the area in between, should be 98% or 0.98. So my confidence level, 98%. And so when I go to do my confidence interval, I'm going to do a 2-sample t interval if you're doing it in the calculator, and then just make sure you use the confidence level of 98%. Otherwise, it's going to be all the same information from the hypothesis test. And in StatCrunch, you have the option as well to do a confidence interval, and then you're just going to say, oh, my confidence level is 98%, and compute that. And so when I do that, I get my lower limit of negative 17 point, want to round this to one decimal place, so 17.5, and then our upper limit is 7.5. So that's our confidence interval for that hypothesis test. And that's how you do that problem.